Good afternoon, everyone. I am Prerna Satilgao. So today I am going to explain you the topic of clustering algorithm in machine learning. Following are the points which are going to be discussed in today's video. First, we'll see the introduction part. Ever wondered how Netflix group similar movies or how photos like Google Photo categorize your pictures? Have you ever wondered? That is clustering in action. That means clustering in action. So, we will be understanding what is clustering and their application, their types of algorithms, and where they are used in real life. Okay, so first let's start with what is clustering. Clustering is an unsupervised machine learning technique that groups similar data point into the clusters. For example, you imagine like there are different fruits. There are different fruits in a basket. So how you will remove the similar one? That's obvious that you'll be seeing their specifications like their shape, their color, right? And accordingly you will be grouping that is nothing but grouping all the items. Whatever given to you is nothing but clustering. Okay, so it emphasizes its part of unsupervised learning. Means there is unsupervised learning is nothing but non labeled data, that is unlabeled data. Okay, so real life example of this is nothing but grouping customers by buying behavior, or categorizing song by moods. Like for example, on Spotify app, you daily listen to the song, right? So what you do, you just categorize the song by your mood, right? You just take all the select all the songs which are according to your mood, and you make an album and you store over there, right? Group, you just form a group, right? So that is nothing but clustering. Okay, so we have seen what is clustering. Now let's move forward with the types of clustering. So there are three main types of clustering. K means hierarchical clustering algorithm, and DB scan clustering algorithm. Okay, so first let's see that what's K means clustering algorithm. This type of algorithm divides the data into non-overlapping subset, that is clusters, where each data points belong to exactly one cluster. Okay, now let's see k-means clustering algorithm, how it works. So first what it does is nothing but it chooses number of clusters. Now for example, see, this is an unlabeled data, right? So it will give k-means. When we use k-means algorithm, it gives this to us in a group which is cluster. So let's see how k-means clustering algorithm works. So we have to choose number of clusters. Okay, first step is that. Second step is nothing but randomly place k centroids. Okay, third step is nothing but we have to assign each point to the nearest centroid. Okay, then fourth point is nothing but recalculate the centroid based on mean of the points in the cluster. And last is nothing but repeat until clusters stabilize. So this was an steps for k-means clustering algorithm. For example, let's see an example. A supermarket segment customers into three clusters. Okay, that is low spenders, medium spenders, and premium customers. Okay, what k-means does, it help group them based on their total purchases and visit frequency. Okay, so this was an example of k-means. Let's see. Moving further, let's see what is hierarchical clustering. So hierarchical clustering is nothing but this algorithm builds a tree-like structure, that is dendrogram of nested cluster. It does not require the number of clusters in advance. Okay, now let me tell you how it works. There are two types of there are two types in the hierarchical clustering, that is agglomerative and divisive. In hierarchical clustering, we have two types, that is agglomerative and divisive. Okay, so what does this actually mean? As I told you that these two are the nearest points, so we have took this one cluster and this CD as a second. We can make this cluster as the third and this one is the fourth. So similarly, we are going to create a dendrogram, which is a bottom up approach. So as of A and B, we done A and B, right? Then C and D, we clustered it, right? We have grouped it. So C and D. Later on, we have took E also, and we have clustered E, D, E, right? So this one, okay. Then we have took the whole entire this. So A, B, C, D, E will be clustered. So it is nothing but a agglomerative example, okay, which is called as dendrogram. Okay, so divisive is also the same, but it is similar. It is like uh, agglomerative was the bottom up approach, and divisive is nothing but all the data points start in one big cluster, then split recursively. That is nothing but top down approach. Next we'll see uh, density based spatial clustering algorithm. So this is nothing but these algorithms form clusters based on areas where, you know, where data points are densely packed, and the points in low density areas are considered noise or outliers. Okay, so for example, in earthquake data, like DB scan can find densely occurring uh, tremors in the region and separate them from isolated ones, means they can separate them from the noise, right? So this was an example of DB scan clustering. So we have completed the types of clustering. Moving forward, we'll see the applications. There are different application of clustering algorithm. So first is customer segmentation. For example, Amazon shows product recommendations based on customer clusters. Okay, so this was an example. Second example, biological data analysis, and third is nothing but image segmentation. So these were three examples of applications of clustering algorithm. So let's see what are the advantages and disadvantages of this. So advantages are there is no need there is no need for labeled data, right? It work well with unsupervised data, and it also finds hidden patterns, and there is wide range of applications in this. Okay, so these were some of the advantages. Moving forward, let's see what are the limitations of it. Sensitive to the outliers and noise, which means that it can affect cluster quality, especially in k-means. Okay, or shape and size assumption. Some algorithms like k-means assume spherical clusters, right? So these were some of the limitations of clustering algorithm. Last but not the least, let's moving forward, let's see the conclusion of this topic. So clustering is a powerful tool in a machine learning that help discover hidden structures in data without any labels, you know, like it from e-commerce and healthcare to image and speech processing. Its application are everywhere, right? But choosing the right algorithm is a key, as each has its strength and trade-off. So these were all the points which were covered in the video. Thank you.